Have you ever just looked up at the night sky and wondered how we first managed to, pull those distant stars right down to Earth? Well, today we're diving into the brilliant, super simple tech that did exactly that, the refractive telescope. It's all about bending light, and you're going to be surprised how one tiny little change in the design completely changes everything you see.
I mean, for basically all of human history, we've looked out at the horizon or at the moon, and we've asked that same question. How can we bridge that gap? The telescope was the game-changing answer. It's a device that didn't just change our view of the world around us, it totally transformed our understanding of our place in the universe.
All right, so let's start with the one you probably think of when you picture a classic astronomer, the astronomical telescope. This was the original workhorse, the tool that really opened up the heavens for us.
Okay, so the first and most important piece of this whole puzzle is the objective lens. That's the big one at the very front. You can think of it like a giant light bucket. Its whole job, its only job, is to grab as much light as it possibly can from a faraway star and focus all of it down into one sharp, real image inside the telescope tube.
So, you've got this focused image inside the tube. Now what? Well, that's where the eyepiece comes into play. This is the part you actually look through, right? It basically acts like a powerful magnifying glass. It takes that tiny little image from the objective lens and just blows it up, making it big enough for your eye to see all the details. It's really just a beautiful two-step dance. Light travels for, millions of miles from a star. It hits that objective lens, gets focused down, and then the eyepiece magnifies it for you. It's this perfect handoff between two simple pieces of curved glass. Pretty amazing.
So, what makes this design what it is? Well, it uses two positive lenses. Those are the ones that bulge outwards. And because of how they work together, it needs a pretty long tube. But here's the really fascinating quirk. The image it gives you is inverted. It's completely upside down. Now, for a star, who cares? A little dot of light looks the same upside down. But this creates a huge problem for looking at pretty much anything else.
So what happens when you point that same telescope, not at the stars, but at something a little closer to home? Yeah, that whole upside-down image thing suddenly becomes a very, very big deal.
The source material we're looking at calls this a definite inconvenience, which, I gotta say, might be one of the biggest understatements in the history of physics. It's not just inconvenient, it's totally confusing.
Seriously, just try to picture it. You're trying to watch a ship out on the horizon, but instead of seeing it sailing on top of the waves, it looks like it's floating upside down with its mast digging into the water. For any kind of viewing here on Earth, this design is, well, it's pretty much useless.
But this is where a little bit of genius comes in. This is the Galilean telescope, a design specifically created to solve that upside-down problem and turn the telescope into a practical tool for seeing things right here on our own planet.
So what was this revolutionary innovation? It was shockingly simple. You keep the exact same objective lens at the front, but you swap out the eyepiece for a -1. That's a lens that curves inward instead of outward. And that's it. That one little change fixes the entire problem.
And that one change gives you some massive advantages. First, and most obviously, it flips the image right side up. No more upside-down ships. But second, it actually makes the whole telescope shorter and more compact. So you get a nice, upright image in a smaller, easier-to-handle package. It's a total win-win for looking at things on Earth.
Okay, so let's put these two designs right next to each other, head-to-head, and really see how they stack up.
You can see it right here, a direct line from the parts to the purpose. You've got two positive lenses. You get a long tube and an upside-down image, perfect for the stars. Swap just one of those for a negative lens, you get a shorter tube and an upright image, perfect for Earth. It's such a great example of how one tiny design choice completely changes what a tool is for.
And get this, the unique way the Galilean design works gives it another pretty cool, surprising use. It's not just for looking at things. It's also used in labs as something called a collimator, a tool that can take a wide, messy beam of light and focus it into a tight, perfectly parallel beam. It just goes to show you how versatile the design really is. So, in the end, you have two simple pieces of glass that gave us two incredibly powerful new ways to see our universe. One for exploring the vastness of the cosmos, and another for getting a better look at our own world. This technology absolutely redefined what was possible, and it really makes you think. With today's incredible instruments like the James Webb Telescope pushing our vision even further, what will the next giant leap in seeing finally show us?